Hello guys, welcome back. Today we will again have some very good problems from the Allen test series, and also because you guys in the last few videos I had received a few comments about PYQs being brought, and also old PYQs like the ones when subjective papers were brought when official JEE Advanced and Mains didn't begin. I guess it was at that time it was IIT JEE. Okay, that was the name of the exam, and papers were also subjective. So yeah, I have brought among them a very good question today also, and I will try to bring more, like, because there is an influx of lot of questions from this Allen paper, so I'm trying to balance it between both of them, and I will do surely bring more questions. So let's start off, guys. This is the first question for today, and you may try it out. I will wait for a few seconds. Okay, so I'm starting off now. So basically we have fx being given as a differential function, therefore it is continuous also, which is satisfying this particular functional equation, and after that we have some things given. So before proceeding into the question, what we will do is we will actually first try to solve this functional equation, because without finding out f of x we are like no way into this question, right? So let's do that. So our functional equation is given as something of this sort, which is your f power 1 by 3, I'm writing the cube root as 1 power 1 by 3 x plus y, given to be f power 1 by 3x plus f power 1 by 3y plus 1. Here x and y both belong to real numbers, and also a small criteria or condition has been given for us to find out the value, like maybe a constant or something will come, so to find that value this has been given. So what we will do is, basically I did some tricks to solve this without using much of those differentiation, like I tried out keeping y constant and differentiating this equation as with respect to y, keeping x as a constant, but that didn't pretty work out and the results were not satisfactory. So I have come out with another particular process and I will explain it to you. So what we will do is, let's take some function g of x to be this f power 1 by 3x, and now we are writing this same functional equation in terms of g of x. So basically this thing becomes g of 1 by 3 power x plus y, sorry, not g of 1 by 3, it is g of x plus y, equal to g of x plus your g of y plus 1. And now what I will do is, I will not take h of x because it is already used in the question. Let's take a function k of x, which is basically your g of x plus 1. Basically you might be wondering why I am complicating this. I am actually not complicating. These functions are of no use. Actually I am trying to reach to a point which is actually like the magic step for solving this functional equation, and from that we will actually come back and then things will be pretty easy. You will understand soon. So now let's put off this k of x equal to g of x plus 1. So that then this thing, actually the 1 will be eliminated and we will finally have k of x plus y equal to k of x plus k of y. Now this functional equation is actually something that we have learnt in our chapters. Basically such a functional equation is of the type k of x equal to some constant a times x. So that's it. And now what we will do is, we will now try to reboot back. Okay, basically our k of x was g of x plus 1, so g of x will be your k of x minus 1. So from here we can write our g of x as, from this step we can write g of x as ax minus 1. And now again we'll reboot another step back. So basically if we see this thing, from here f of x will come out to be g of x whole cubed. So from here f of x comes out to be ax minus 1 whole cubed. That's it. And now let's use this small condition. We'll differentiate this equation one time and see. Let's do that. So our condition given was f dash 0 equal to 3. So let's find out f dash x. Your f dash x will become 3 times ax minus 1 whole squared, and like differentiating this thing we will get a. So if we put f dash 0 as 3 and put x equal to 0, I guess we will get 3a. So basically your a becomes 1. So we have our final f of x ready with us. F of x is nothing but your x minus 1 whole cube. Now we are kind of ready to proceed furthermore into the question. Let's read the question once again. So basically we have a function h of x which is given out to be f of x minus x cube, and there is a set A which contains a point. I don't know what was there in these boxes, but I guess A will contain a point where h of A will actually be the set of all those points such that h of mod x is non-derivable, right? Something of that sort. And then we also have another thing, let x power, I don't know what this is written, I guess 0, is solution of the equation f of x equal to f inverse x, and then we have to find this. Okay, it's not x power 0, it's x naught. Okay, this thing, please correct this guys, I don't know, pretty bad typing mistake, but anyways, that is x naught. Like in physics we say this subscript, we tell it as x naught, so I'm telling it here also as x naught. So let x naught is a solution of the equation fx equal to f inverse x, and then we have to find out this large thing. Basically we have to calculate all the parameters. So let's do that quickly. I will first try to find out h of x. So our h of x was given as f of x minus x cube. This is x, okay. So x minus 1 whole cube minus x cube. And now what you can do is, what I would recommend is, rather than opening this bracket and manipulating all that, it would become a really hectic expression. So what we will do is, we will try to apply a cube minus b cube. So a cube minus b cube will come out to be your a minus b times a square plus ab plus b square. So here x and minus x, they get cancelled. So basically a minus outside, and h of x becomes a minus outside. And from here x square and another x square, so 2x square, and your minus 2x and minus x, so minus 3x, and plus 1 from here. And I don't think, okay, there is an x square here also, so this will be 3x square. 3x square minus 3x from here, and I guess plus 1 is alone. So this is our final h of x. And now we need to obtain the curve for h of mod x, right? So I guess if we try to check out, let's check this discriminant of this equation quickly. So discriminant is your b square 3 square minus 4 3s are 12, which is less than 0. That means this thing is actually not intersecting the x-axis anywhere. And also if we multiply the minus sign into this, the coefficient of x square is negative, which basically means that the curve for h of x is lying just below the x-axis. That is a simple conclusion. So I guess now we can proceed to draw the graph for h of mod x. So let's do that quickly. So for doing that, first we will go on to the graph of h of x. So basically to draw the graph of h of x, I am not going much into the calculation for, I guess you guys know this. If we have to try to find out like minus b by 2a comma minus d by 4a, I don't exactly remember what this quantity is called. I guess it's the vertex of the quadratic equation, parabola, the vertex of the parabola, right? So if you actually find out this thing, this will come out to be, I am writing the answer. This is actually coming out to be your half comma minus 1 by 4. This is just for ascertaining the graph little bit. So if we try to draw the graph is looking something like this. As per my calculations, this thing, this is half comma minus 1 by 4. So if we take this to be half, say this is 1, so somewhere here. And this thing, I guess, what we can do is we can try to put x equal to 0. Okay, I will, just a minute, I will do that. So basically what you will observe is, this is your vertex and this is actually intersecting the y-axis at one particular point. Okay, that is your 0 comma minus 1. I quickly calculated this from here. So basically this is your graph of h of x, and now you can draw the graph of h of mod x pretty easily. Just this part we have to reflect it on the other side. So let's do that. So now if we draw the graph for h of mod x, it will look something like this. Here's our coordinate axis. We don't really need the upper part, so I have drawn this short. And now I guess the graph will be something of this sort. If we take, say, if we take this as a horizontal line, maybe if this is this, so somewhere here, it will go something like this, right? Basically the thing, that part of the graph which went down here, I just reflected this particular part. This is pretty simple, I guess. No clarifications required. So this is minus half and this is your half. If you want to know this point, this is your 0 comma minus 1. So basically I guess we had to find out mod A, the number of points where this thing is actually non-derivable. So non-derivable or non-differentiable means a sharp corner. So basically, as you can see, there's a sharp corner only at one particular point. So mod A becomes 1. Only one particular point has a sharp corner. So that's it. And we have another thing also where like lot of they have mixed up everything in this question, inverse trigonometry, and after that like using graphs we have to particularly calculate some inverse trigonometry values, which is actually the next part. If you see the next part, it says that f of x equal to f inverse x. Typically we have to draw this graph also. Okay, so our f of x was x minus 1 whole cube. So if you know x minus 1 whole cube, it will particularly have roots at r x equal to first is 1. And if we try to calculate like at if this is intersecting somewhere at the y axis or not, I guess yeah, it will intersect at y equal to minus 1 also. Okay, basically for drawing the graph I am ascertaining all this. So let's try to draw the graph, okay, for this function. So if we try to draw the graph, let's take the coordinate axis like this because we will not typically need this side. So let's say this thing is your 1, this thing is your 2, and also because we have to find out f inverse x, so typically we have to take y equal to x. I hope you guys are familiar that fx and f inverse x, their graphs will be mirror images across y equal to x. Okay, so now we have our y equal to minus 1 here. So basically the graph is going something I guess like this. Let's try to draw it. Like I will draw it in a more concave way. The curvature will look something like this. Something of this sort. Okay, this is not a straight line. I am drawing it in freehand, so maybe the graph is not looking that good. And after this point, I guess it will go something like this. And at some particular point, obviously, it will cut off y equal to x. Because if we try to solve this, like x equal to x minus 1 whole cube, actually, if you try to solve this, you will get an equation. And after you differentiate that equation one time, you will actually understand that this equation has some real roots. God knows what, but yeah, it has real roots. Basically, reason being that if you observe the graph of f inverse x also, you will understand that it is also intersecting at this same point. Now I will explain how. Okay, I will explain that how we can ascertain. So basically if we take minus 1 to be somewhere here and try to draw the graph for f inverse x, it will come something like this. It will I guess intersect at 1. So this is your 1 and this comes something like this. Like I know my graphs are pretty bad and these are not really looking like mirror images, but please do bear with me. Like these two are mirror images. Okay, this is your f inverse x and this is your f of x. So yeah, they are actually like intersecting at some point, but we have to ascertain where. Okay, so let's try to find out like our f of x is your x minus 1 whole cubed, right? Let's try to find out a few values. What I will do is let's try and find out f of 1 is already a root. We know f of 1 is 0. No point in finding out that out. So let's find out f of 2, because as I can see 2 is here. Although I drew the graph like this, but like I have not still ascertained anything. Okay, don't like think that how did I know after 2 this thing is intersecting here. I just drew this in freehand and we will try to ascertain where it will actually intersect in which interval. Maybe I have to change this to some other point. Let's see. So if we try to find out f of 2, that's coming out to be 1. And if we try to find out f of 3, this is coming out to be 2 cube 8. And if we try to find out one more value, I guess this will go on till 4 minus 1, 327. So I guess this to this jump is actually much greater, right? 7 difference and 21 difference. I guess in between 2 and 3 somewhere it will intersect, as much as I can understand. I guess in between 2 less than x less than 3. Like x naught will lie in between 2 and 3. And x naught was, like, if we have this thing 3 here, I guess in between this 2 x naught will lie. This will be our x naught. I guess that's it. Because this was like, now you will ask me that why is this interval basically important? Because if you guys remember in the question, we have to calculate something. I will write that out. This is your cos inverse of cos 2x naught plus 4 times tan inverse of tan x naught by 2. Have to calculate this thing. And if you remember, cos inverse cos x and tan inverse tan x have different values at different intervals, and that was the damn reason why I found out this thing. Otherwise you won't be able to ascertain like in which interval, right? Because there are many values, from the graphs. Like if we try to draw cos inverse cos x graph, it something goes like this. This is your 0, this is your pi, this is your 2 pi, this is your 3 pi. So to ascertain, we have to typically know this thing. So from the graph, I'm not going to like much of explanation into this thing because this is pretty easy. This thing actually becomes your 2 pi minus 2x naught. Okay, because if you see from here, 4 is less than 2x naught is less than 6. And I guess your 2 pi is approximately 6.28. So not there, but yeah. Pi is your 3.14 and this is your 6.28. So maybe somewhere in between these two parts, somewhere in between it will lie. So basically this will be the line. So yeah, I don't think this is much of explanation is needed. And this thing is simply your x naught by 2. So basically what you will see is minus 2x naught and plus 2x naught get cancelled. So this is 2 pi. It was pretty shocking because what we did all this hard work and x naught actually was worthless. Okay. Anyways, this was it, and now I will once look into the final result, like what we had to find. So basically we have to find out 1 by pi times of this particular expression plus r mod a, which comes out to be 1. So our answer for this question will become 3. Let's look into which option was correct. So basically our option C for this question becomes correct. This was a very good question, like mix of, I guess, 1, 2 and almost about 2 to 3 chapters were mixed. About 3 chapters were mixed, right? So this was a pretty good question. Like this can consume some of your time, although I am solving it on board, so maybe I will take 3 or 4 minutes extra. But in the exam hall, please remember your target question for JEE Advanced would be only having a time of about 10 minutes. Or 10 minutes is actually much greater. Maybe even less than that. You can have 7 or 6 minutes also. So that completely depends on the exam situation. Anyways, this was a good question. Now I will proceed on to the next question for today. So here's our next question for the day. So you can try out this question also, guys. This is like not very difficult, but yeah, conceptual question, really good at the concepts. So you can try it out. I will wait for a few seconds. Okay, so I'm starting off now. So let's read the question once because there is some sort of complexity in the language. So basically we have 3 circles of radius 3 and their centers given, and a line of slope m is passing through point 3 comma 0 such that the total area of the part of the 3 circles to one side of the line is equal to the total area of the 3 circles to the other side of it. Basically the line will divide these 3 circles in such a way that we will have a part of the area of 3 circles on one side and a part of the area of the 3 circles on the other side, which means basically the straight line has to be constructed such that 3 circles are on both sides. Maybe there can be a part of one circle, but yeah, 3 circles have to be there on both sides. So in accordance with this, first I will try to draw a rough diagram, like say this is a line. Okay, I will draw it straight. say this is our reference line somewhat. And now if we draw the circles, something like this, okay. Let's say these are our 3 circles. Let's say this is your B, this is your C, and let's say this is your A. And here are and this is lying on the line itself. So this is somewhat the diagram, and our points, I will also write them down. These are A0, 16, B3, 0, and your C5, 8. So now as you can see, actually the purpose for drawing this diagram was that we have actually drawn our line of reference, the line which is given here. If you observe, on one side of this line we have 3 circles, like part of 3 circles, and on the other side we have part of the other 3 circles. Actually, if you draw the 3 circles, there will be no other way, no other line to actually divide them in the manner said in this question. And like, it's total area of the part of all 3 circles. So it doesn't matter if any circle is not in, like, in any part, or in none of the 2 parts, all the 3 circles have their whole area. They are basically present in parts, but that is allowed as per the question. So now I guess time to proceed with some sort of calculations and all. Now if you see something carefully, basically this particular line is joining, rather I will not say joining, basically passing through 2 circles as a secant, okay. And if you read on some properties of circles, you will understand that if we take a line that is joining, say, AC like this is the line joining AC somewhat, okay. If this point is, like, the line AC is intersecting this particular line in this point, actually this point becomes the midpoint of AC. If we take it to be, say, some point M, then M is your midpoint of AC. There are basically many ways to prove this. Either what you can do is you can construct a diagram like this, and I hope this is something that most of you have learnt in your class 10s. This is your similarity of triangles, right? This is your, these two sides are equal, like completely equal, and you can also use an included angle if you want. Basically, I guess whatever you do, and also you will have a vertically opposite angle, right? So I guess it is sort of SSA symmetry. You can actually like prove, either you can use congruency or you can use your similarity of triangles. Either way you will get this particular thing. So I'm not going into that explanation. So basically now we have things ready with us, and what I will do is, now I will do one more thing, that I will try to join, just a minute. Okay, so basically what we can see is we have to like ascertain the slope of this line, right? Which is available to us now because we have M point and we have B point. So we can easily calculate M, I guess, no issues. This was a very, like, this particular place is actually the thing which gave us the answer to this question. Otherwise the question is sort of like easy, but yeah, you have to notice this part. Like, your basics should be very clear. That is why always it is said that your basics should be very clear and you should not forget what you were taught in class 10th. Pretty good lesson anyways. So the midpoint of this is coming out to be your 5 by 2, and 16 plus 8 is 24 by 2, so 12. So now if we try to calculate the slope of the line MB, it B is your 3 comma 0, so 12 minus 0 is 12 divided by 5 by 2 minus 3 is your minus half. This thing comes out to be minus 24. So we have to find out mod M by 8. So mod of minus 24 by 8, and our final answer comes out to be 3, which is your option number C. So as you can see, this was not a very good, like, very long question, but yeah, fundamental concepts required were, first is constructing this diagram, because like there would be a percentage of people who would be wondering about how to construct this line so that this is made, and even if you have constructed the line, you will need 2 points, and that is where you can think about this, right? Anyways, I will try to proceed to the next question now because this is done. So here's our next question, and finally we have a question on integration, and because you can see in the options we have to also do comparison. So basically this question is based on a very good topic, which is inequality on integrals. I hope you guys know that. So you can try out this question. This is a very good question in my respect. You can try out this question. I will wait for a few seconds. Okay, so I'm starting off. So basically our integral I is given to be something like sigma k equal to 1 to 998 integral k to k plus 1 k plus 1 whole divided by x into x plus 1 dx. Now we have the limits k to k plus 1, right? So let's define something. What I will do is, like, x is here belonging to k plus 1, right? Because the integral is in dx. So for x belonging to k plus 1, if we observe carefully, our x plus 1 will be greater than equal to your k plus 1. I hope this is understandable. Like, x plus 1 will be either greater than or equal to k plus 1. So now if we, like, take this thing to the denominator this side, we will have k plus 1 by x plus 1 less than equal to 1. And now if we multiply both sides with 1 by x, we will have k plus 1 divided by x into x plus 1 less than equal to 1 by x. Now the reason I did this because we have to calculate inequalities, so we need a relation, right? And this is our relation. So now we will punch into this particular expression our sigma and the integral given. So let's do that. So therefore we have sigma k equal to 1 to 998. Just a minute, guys. Yeah. So this is sigma k equals to 1 to 998 integral k to k plus 1. And this side we have k plus 1 whole divided by x into x plus 1 dx less than or equal to sigma k equals to 1 to 998 integral k to k plus 1 dx by x. And now this is simply our I. And also what we can find out is we can integrate this thing pretty easily. So dx by x, that is sigma k equals to 1 to 998, and this thing becomes your ln of k plus 1 minus ln of k. So ln of k plus 1 by k. And now this will basically become a series. If you notice, ln of k plus 1 minus ln of k, and sigma from k equals to 1 to 998. So if we start putting, this becomes ln 2 minus ln 1. Next term will become your ln 3 minus ln 2. So ln 3 will get all obviously cancelled later on, but first ln 2 and minus ln 2 will get cancelled, then ln 3 minus ln 3. And now as you can notice, because we know this, right, if the first pair, if the first term gets cancelled and the last term remains in the first pair, basically in the last pair the first term will remain. So what will remain is your ln 998 plus 1 minus ln 1, and now ln 1 is basically 0. So basically this value comes out to be ln 999. I will change the page once. So here we have your I less than equals to ln 999. So I guess option A will be one correct option. Now we have another inequality given, like I less than 6 and I greater than 6. So basically question isn't finished yet. So we have to ascertain that also. And now if you observe carefully, we had something written here, right? From there we concluded one thing, that x plus 1 is greater than or equal to k plus 1. But we can also conclude something else, that our x is less than or equal to k plus 1, right? We can conclude. So now what we will do is, just a minute, we will do the same thing like what we did here. Okay, basically sort of same. I will take x to the denominator, so k plus 1 by x is greater than or equal to 1. And in the next step we multiply 1 by x plus 1 to both sides. So k plus 1 whole divided by x into x plus 1 is greater than or equal to 1 by x plus 1. So this time the integral is a bit different. No issues for that. So what we can write from here is sigma k equals to 1 to 998 integral k to k plus 1, your k plus 1 by x into x plus 1 dx is greater than or equal to sigma k equals to 1 to 998 integral k to k plus 1 dx by x plus 1. This is it. We could have written this in one step also, I guess. That would have been more convenient rather than all this mess. Anyways, let's calculate this thing. So if we try to calculate this, this is your I. Anyways, and this thing is your integral sigma k equal to 1 to, I guess, 998 integral k to k plus 1 dx by x plus 1. So we have sigma k equals to 1 to 998, and this is your ln of x plus 1. So basically this will summation will be ln of x plus 1 and these limits. So ln of k plus 2 minus ln of k plus 1. So if you actually see something similar to the previous thing will actually happen, and you will get this thing to be, I am calculating this thing for you. This will actually become greater than or equal to ln 500. Okay. This will become greater than or equal to ln 500, and now what we will do is we'll try to ascertain this value. Although they should have given ln values, they will definitely give you this in the JEE advanced paper. Okay. If you guys wonder about whether log values will be given to you in the maths section or not, then you can be pretty rest assured, because in my paper in 2025 when I gave my paper, I myself saw everything was given. Okay, even small, if you notice some questions, even the small root to 1.14 values were also there in one or two questions, I can remember. So for maths you can be rest assured, but yeah, for chemistry and physics I can't guarantee, because I should not comment on that anyways. But yeah, chemistry, as far as I remember, in the integer type questions, there were numerous questions from those chapters like solutions, and there were many other chapters in the end which are not included in JEE mains. Like if you remember, we had solutions, we had surface chemistry, we had solid state. So surface chemistry, solid state, both were asked this year, one and one question, which was shock for those people who didn't do. Anyways, but there we didn't have the ln values given. Okay, we needed ln values in both those questions, but nothing was given. So yeah, I would recommend that. It would be a little, it might be a little tough, but for damage control, please do remember ln values. I also don't remember, but you should remember. Okay, so let's try to calculate this thing out a little bit. So this thing roughly comes out to be your 6.214. So basically your I will be greater than or equal to 6.214, or because we have 6, so I will be greater than 6. Let's look out which option was that. So yeah, I greater than 6 is present in our option D. So our option A and option D will be correct for this particular question. This was a good question on inequalities, like pretty good question. I like this. So now I will proceed to the next question. So here's our next question for the day, and this question is based on probability and is also a very interesting question. Like, I don't exactly remember, but something which is based similar, like very similar to this. The concept in the question was the same, but the like outside portrayal was different. There was something else, but the concept used was the same, and the question had a few more parameters also. Such a type was asked in JEE Advanced in some previous year. I don't exactly remember. Anyways, you can try out this question. I will wait for a few seconds. Okay, so I'm starting off. So let's read the question first. So basically we have an electrical apparatus A with three components C1, C2 and C3 as given in the diagram. The components work independently of each other with the probabilities 8 by 10, 9 by 10 and 3 by 4. So let's write them down. Probability of C1 is your 8 by 10. As you can see, C1, C2, C3 are the probabilities or the events that they are functioning. Okay, this is your C. Probability of C2 is your 9 by 10. Probability of C3 is your 3 by 4. So now what they have given us is for the apparatus to be operational, the current starts flowing from left to right. So a little bit of physics also we need to understand. The current flows from left side to right side. Let X denote the event that apparatus is operational, and X1, X2, X3 denote respectively the events that the components C1, C2 and C3 are functioning. Basically our apparatus A is an ammeter. Okay. If you are a JEE aspirant, you will understand this anyways. So let X denote the event that the apparatus is operational. So basically let's draw this circuit. This is your C1, C2 and this is your C3. So what you can see is, okay, we have to like go on to the options, I guess, at first. So we have been given a few options, among which we have first there is that probability of X is your, not X, probability of exactly two components. Okay, I went into option B by chance. So probability first, in the first option we have probability that exactly two options are functioning given X equal to 1. Okay, so for that we have to find out probability of X first. So X is basically the event that the apparatus is completely operational. Basically operational meaning that the ammeter will have some current passing through it and the ammeter will show some deflection. Okay. So I don't have to say, like, you all know much more physics than me, I guess. So for this ammeter to be operational, basically current has to like pass through these two. And now what will happen is, if any of C1 and C2 are not working, then this circuit will basically break. And because this is a parallel connection, so if only the current passes through C3, that will not be viable. That is some sort of a basic idea. So now what we can do is we can write down the probability of X. And also there is one thing that I would like to explain here. Like, if you guys see carefully, C1 and like, I will write the expression. It would be better for you to understand. This will be probability of X3 plus probability of X3 complement intersection with X1 intersection with X2. Now you will ask me why. Basically because if the component C3 works alone, ammeter will obviously show a deflection. But if component any one component among C1 and C2 breaks, then also we have an alternate pathway along C3, right? Like, basically, if you know in physics, if an ammeter has to function, it has to receive current. Otherwise, the ammeter will not show any deflection. So basically, there has to be a pathway for the current to pass through the wires. So if any one of C1 and C2 is defective, although this wire will break, but there is still a pathway through C3 for the current to pass. But that doesn't happen if C3 completely breaks and C1 and C2. Okay, I guess you can understand. So now we will try to write this. So these actually can be the two cases where the apparatus is operational. Now, if there had to be a case where the apparatus is not operational, I will also explain that in case they ask the question. So basically that case would be, it is only possible when, because you can see, right, if C3 is broken, still C1 C2 is a pathway. If C1 C2 among those one is broken, or maybe both of them are broken, then also there is a pathway through C3. So basically the only condition when it will, like, not only condition, I guess there will be 1, 2 and 3 such conditions. So those condition will be when C1 is working, C2 not working and C3 not working. When C2 is working, C1 is not working and C3 is not working. Or there can be a third condition also if all three are not working. These will be the three conditions when this ammeter will actually show no deflection. Okay. Otherwise, this is actually the possibility where the ammeter is operational and it will show some deflection. So that's it for the explanation part. Now let's quickly calculate this. This is your probability of X3, that is this thing. So 3 by 4 plus probability of X3 complement, so that becomes 1 by 4, 1 minus 3 by 4, I'm not doing that extra, and your 8 by 10, and this is 9 by 10. So basically 3 by 4 plus 72 by 4 into 100. So I will change the page and add this up. So basically if we take a 1 by 4 common out from here, and this will become 3 plus 72 by 100. So now this is 100, I guess 300 plus 72. So 1/4 of 372 by 100. So I guess if we try to cancel this, this is your 2 ones are 2, 8s are 16, 6 are 12, and this thing becomes 2 9s are 18, 2 3s are 6. So I guess this is coming out to be 93 by 100 here. So let's check the option once. Okay, it is given that a by b, then b minus a is 7. Yeah, it is very correct. B minus a is equal to 7. So yeah, our first option B comes out to be correct. Now we can proceed on to option A, where it is we have basically a conditional probability, the probability that exactly two components are functioning given x. Basically it tries to mean that the probability that any two components exactly are functioning given that the ammeter is operating or the ammeter is functional. So basically what we have given here is that not it is equal to 1. So yeah, this thing will be false because it is not equal to 1. And like if you want proof for that, so basically the proof lies here. Basically if we fault C1 and C2 both, still C3 has current passing through it, which is seen clearly here. Like if we fault C1 and C2 both, still current will pass through C3 and the ammeter will be functional. So this is not always true. So basically not 1. So our option A is wrong. So now let's move on to our option numbers C and D. I will change the page. So our option D was probability of x given x2. Basically x given x2 meaning probability that the ammeter is functional given that the second component or C2 is working. So this is pretty easy. This thing will actually become, I will try to write this in expressions. This thing will become your probability of, I guess, x1 into probability of x2 plus probability of x1 into, I guess this thing will be your probability of, okay, not x1, x2, and I guess probability of x1 complement. Okay, I hope you guys can understand. And another will be probability of x3 this time, and this will be whole divided by your probability of x2. So now we can write this as 9 by 10. I hope this part was clear. Okay, I'm not going into the explanation further because I have given it above already. This is 9 by 10 into 8 by 10 plus 9 by 10 into 2 by 10 into 3 by 4, and this thing is whole divided by your 9 by 10. So 110 gets cancelled from everywhere. So this thing becomes 72 by 10 plus, let's do some cancellation. This thing is your 2 2s are 4. So 9 3s are 27 by 20. And this is 1 by 9. So basically this thing becomes 8 by 10 plus 3 by 20. So this is your 16 plus 3 by 20. And so this comes out to be 19 by 20. Which was, I guess I will check the option D once. So yeah, option D is correct. It's given to be 19 by 20. And now let's check on option C as well, where it is given that probability of x given x3 is equal to 1. Basically what they mean to say is that we have to find out the probability of the ammeter being functional or the ammeter showing deflection given that all the three components are working. So if all the three components are working, like, then there is absolutely no probability of the ammeter not functioning. So basically C is also correct. This is basically common sense. Okay, no need to calculate. Like it is given that the ammeter is functional, like, sorry, the probability of the ammeter being functional given that all the three components are working. So if all the three components are working, then there is actually no like breakage in any of the components. And what we saw was even if C1 C2 are both broken, then also through C3 the ammeter will work, and here we have all three working. So basically the probability of this thing will be obviously 1. There is no probability of the ammeter not working when all the three components are working. So basically our correct options for this question will be B, C and D. This was a pretty good question on probability. I like this. So now let's move on to the next question. So here's our next question. This is an easy question, like you can say this is a trick and treat question. You can try it out yourself. I will wait for a few seconds. Okay, so now I am doing the question. So basically, if you observe our system of equations, I will write them down. This is x plus y plus z plus w equal to 1. This is your x plus 2y plus 4z plus 8w equals to 16, and x plus 3y plus 9z plus 27w equals 81. And also another equation, which is your x plus 4y plus 16z plus 64w equal to 256. Now if you have already observed these four equations, there is a pretty good pattern that you can see, which is that if we take all of these terms present on the left hand side to the right hand side directly, then you will see that this is actually an equation, which we can write, if say we write it in terms of n, this is n power 4 minus wn cube minus zn square minus yn and minus x equal to 0. Basically, the roots of this equation are your 1, 2, 3 and 4. That is what they have meant to say. And now this question has pretty become simple. I'm not going into the calculations. What you can do is, because you have the roots available now, w, z and w, z, y and the coefficient of x is already there. So you can find out all these coefficients using your properties of quadratic. Like this will be sum of the roots, this will be product of the roots taken, I guess, 2 at a time, this will be 3 at a time, and so on. You can do that. So I will quickly write down. W will become your 10, Z will become your minus 35, and Y will become 50, X will become minus 24. And now we don't need the negative values, we need the values in mod. So mod W is basically 10, mod Z is your 35, mod Y is your 50, and mod X is your 24. So now we had to ascertain that the pair which has highest common factor as 2. So let's factorize all these out. This is 5 into 2, some kid stuff that we have to do right now. Anyways, everything is important. So 35 is 5 into 7. 50 is your, I guess, 25 into 2. So 5 square into 2. After that we have 24, which is, I guess, 3 into 8. So 3 into 2 cube. So let's check on the options directly. First is your W and Z. So 10 and 35. 10 and 35, no, 10 and 35 will have HCF as 5. So option A is gone. I hope I did correct. Yeah, W and Z. Okay, Z and Y. So 35 and 50, I guess this also no, because 5 here will be the HCF. So that is also gone. In C we have mod Y and mod X. So 50 and 24. Yeah, here 2 will be the HCF. So option C becomes one correct option. Let's look out if there is any other correct. In the final option D we have mod Z and mod X. So mod Z is 35 and mod X is 24. 35 and 24, no, there is no common factor at all. So D is also wrong and our correct option is only option C. This was a trick and treat question. Like, good question, but easy. So now we will move on to the last question for today. So here's the question, guys, and I guess this will be the most beautiful question for today. This is a very good question. So you can try it out and I will wait for a few seconds. Okay, so now I am starting off. So basically we have a function. Basically they have given all functions. So I guess because of the constant, the functions might differ also. Yeah, it's possible if we integrate. Although we don't need to integrate because we only need to find out what is given in the options. So we have to find everything regarding the function. We have to find f double dash x. We have to find f of x, whether in which interval it is increasing. We have to find many other things. And as far as I can look at option D, I guess this is some sort of intermediate value theorem also involved. or maybe Rolle's theorem, I don't know. Okay, it's minus. I guess intermediate value theorem might be involved. Okay, anyways, let's head on into the question now. So f of x is given out to be your integral 0 to x square cosine 1 by root t plus 1 dt, where your x is greater than equal to 1. So let's differentiate this first. Okay, first thing that we do. So using L'Hopital's we can differentiate. So x square will get differentiated to be 2x, and we put x square into the expression. So this becomes your 1 by x plus 2x, which is greater than 0 for x belonging to your 1 to infinity. So now basically I wrote this thing because we need to check, right? Okay, I haven't checked, still I wrote. I shouldn't have written this earlier. Let's check it out first, then only we will write. So this is our expression, and now we have to find out everything about f dash x. If f dash x is greater than 0, that means in this particular interval our f of x will be increasing. So in 1 to infinity of we observe like x is always positive, so this thing is positive, this thing is also positive, and cosine 1 by x, I guess it's nowhere negative. So yeah, why did I cancel this out? Anyways, better to write after concluding. For x belongs to 1 to infinity, our f dash x is coming out to be greater than 0. So yeah, this is an increasing function. F is increasing. So option A becomes correct. And now let's proceed on to find out f double dash x, because we have to evaluate a limit also. So f double dash x, this becomes I guess 2 cosine 1 by x first when we differentiate x and keep cos 1 by x as constant, and after that 2x, and this will come out to be minus sine 1 by x first and then minus 1 by x square also, and a plus 2 at the end for 2x. So this basically comes out to be 2 cosine 1 by x plus minus minus plus, so 2x and I guess x by x square, so 2 divided by x, and this thing is your sine 1 by x plus 2. So this is obviously positive, and if we tend x to infinity, or rather we have it given also that x is always greater than equal to 1, right? So basically if x is always greater than equal to 1, I don't think there is any negative term here. So yeah, this is also greater than 0 always. So now let's put it into the limit and solve. So here's our given limit, which is limit x tends to infinity f of double dash x. So now if we solve this, I guess we have a lot of 1 by x terms here, so not mingling with that, let's put limit y tends to 0. So 2 cosine y plus 2y sine y plus 2. So if we see cos 0 is 1, so this comes out to be 2. Y is tending to 0, and although this thing can be replaced with y again, like sine term can be replaced with y, but 2y square, so this whole thing will go to 0. And here we have cos 0 1, so 2 plus 2, and this comes out to be 4. Pretty simple. So B option is also correct. And now what we will do is to ascertain, like, okay, we have also something of f of 2, f of 4 given. Okay, let's solve this thing first. So what I will basically do is, before moving on to the last option where we have to do that, don't know, Rolle's theorem or intermediate value theorem. So before moving on to that, we will try to find out whether this particular thing is actually correct or not. Okay. So there can be rigorous ways to prove this. One very popular way that, like, this is, I have seen the use of this thing in Olympiads. Basically what they do is they approximate the value of this expression, because as you can see we had integral 0 to x square cosine of 1 by something, right? So basically many people, what they do is they try to approximate this expression. There is a method called approximation. I don't know whether it is actually in our syllabus or not, but yeah, this is used in Olympiads and there is a method called approximation. But yeah, because we are in JEE, so we will not use any approximation. We will try to find out things just as they are. So what I will do is, let's try to like prove this to be wrong or correct. Okay, I'm for the time being considering that this is correct. Maybe like let's go on a few steps and then we will, I guess, gradually understand seeing the situation that whether this thing is correct or not. So let's write our f of x, which was basically integral 0 to x square cosine 1 by root t plus 1 dt. This was our f of x. And so now what I will basically do is I will try to rewrite this inequality. Okay, basically I will do something. Let's take f of x to be some I of x squared. Okay, so from here f of 2 will become your I of 4, f of 3 will become your I of 9, and f of 4 will become your I of 16. There are easier ways to do this, but I am just doing some brainstorming because God knows this might get somewhere useful to you, maybe. And I have seen this procedure in a very famous calculus book, so that is why I am applying it here, because I have the chance. So now if we can rewrite this expression in terms of I, we can say I4 plus I16 is greater than your 2 times I9. This is what we have to show to be wrong or correct, whatever. Like, let's for the time being consider that this is correct, and we will obviously know if it is not. So let's rewrite this thing. This is your I4 plus I16 minus 2I9 greater than 0. And please also notice one thing, the limits here in the integral will be also changed. I will write this as I of x to be your integral 0 to x cosine 1 by root t plus 1 dt. Okay, limits will also change. So now let's try to write this in the integral form. So what I will do is, because all the integrals are here, so I am taking the integral sort of in one bracket. Okay, although I don't think this is a good way of representing, but anyways I am writing it just for convenience. So I grouped all the integrals into one bracket, and this thing will be directly your cosine 1 by root t plus 1 dt. I don't know if this is a very correct way of representing this, but opening this and writing is very hectic, so I just wrote this as a shortcut, please don't mind. So now let's group the intervals. Basically what I mean is we can write this to be integral 0 to 4 cosine 1 by root t plus 1 dt, and then we will use, basically we will write this as integral 9 to 16. I hope you understood why, right? Cosine of 1 by root t plus 1 dt and minus of integral 4 to 9 2 times of cosine 1 by root t plus 1 dt. So now if we take this thing to the other hand side, I will just put the directly greater than equal to, this is what we have to basically prove. Now let's try to analyze the behavior. So the whole point of writing all this thing was to take this small expression as g of t equal to cos of 1 by root t plus 1, and now I will show you something. Basically what you will see is our g of t is obviously residing in between 0 to 2. I hope this has no confusions. Also g of t is increasing on 0 to infinity. I hope this is clear. I just hope this is clear. So if g of t is increasing on 0 to infinity, basically what we can conclude is cosine 1 by root t, right? So 1 by root t will be obviously decreasing, right? If 1 by root t decreases, then only this thing will increase. So that means if we take cosine 1 by root t, as you guys know, if we have such type of functions, they usually, when they reach the origin, they start oscillating. I have explained this in one of my previous videos also. If you see that video is uploaded on my channel, if you see that controversial question which we had in JEE Advanced this time, that 2x sine 1 by x question, that very very similar to that, not exactly similar but very very similar. So that thing I have explained there with references to books, with the drawings of the graphs, with everything I have explained there beautifully, how the this oscillation thing goes on and what sort of things happen. I have explained everything, so you can go to my channel and watch that video if you want. It's very helpful. Okay, I guess I spent about 50 minutes just trying to explain a single question, and I did complete post-mortem of that. So you can go and check that out if you want. Anyways, so if we see this particular thing, basically it is as it tries to reach the origin, the oscillation frequency will actually get slower. And it is also tending towards 1 to the right hand side. Okay, right hand side meaning in this direction. It is somewhat tending to 1. So if g of t tends to 2, right, as t tends to infinity. I hope this was clear from this part. So if we try to see over an interval 9 to 16, which was I guess basically here our reference interval, as you can see. If we try to see our interval 9 to 16, here from this particular part we can conclude something. As the oscillation gets slower and g of t when it is tending to 2, t is tending to infinity, what we can say is over 9 to 16, g of t is actually closer to 2 than over 4 to 9. This was the basic funda I was trying to explain with all this. I hope this was clear and I could make you understand. And one more thing which you can notice is that if you try to find out this particular thing, observe the nature of integral 0 to 4 g of t dt, you will understand that it is very very large. Basically why? Basically because the g of t we are talking about here in the reference interval 0 to 2. Now this is 0 to 4. So by the time it reaches 4, oscillation will become very high. You can say, like, explain it in that way. The oscillations will become so high that this thing will be positive. Obviously it will be positive, but this thing will be also very very large. Okay, that's a pretty clear indication to prove this fact. Anyways, so this thing becomes very very large. Okay, as it surpasses 2 here, as it will reach 4, the oscillation which was here, as it tries to reach 4, the oscillation will become very very high. This is pretty clear. You can, like, if you want me to make a separate video on the maybe the nature of such curves, because the method I am using here, right, this is actually, if you look into various famous books, like I gave you one book in that controversy video. I don't remember the, I guess it was counter problems in calculus or something like that, the name. You can check it out there. So in that book, as well as also as well in the other famous calculus books as well, this is explained in a very famous book, J.K. Bansal for calculus, if you have heard the name. There also it is explained in this method, basically an oscillation method. And standard calculus books basically try to explain all this using oscillation methods instead of going for those tedious differentiation and things. Okay, so I guess it is pretty clear now. So if you try to, like, double this particular value, even if you try to double this particular value, you won't get this to be equal to ever. We took this to be greater than equal to from here, but here from all this theory it is proved that it cannot be equal to, it will be always greater than. So yeah, our option number C was correct. I don't know if you guys like this explanation. You can tell me if you didn't, or maybe I could have gone for the simpler one. But this is something that standard calculus textbooks, good textbooks, usually recommend, and they explain in this procedure. That is why I took a hold, because there was a chance, so I tried explaining in my own ways. Okay, so let's proceed, and we always have a last option left still, so let's do that. So let's move on to our option number D. where I will just look at, I guess it was given something to be like f dash x plus 3 minus of f dash 3 to be greater than 12. We had to ascertain whether this was true or false. So let's do one thing. Let's find out f double dash x. So guys, I have already calculated this, okay, so I'm not going above and showing you. You can just like go, I guess, about 30-40 seconds earlier and you can get the f dash x there. I'm directly writing f triple dash x. So this will actually become 2 by x square sine of 1 by x minus 2 by x square sine of 1 by x plus 2 by x sine, I guess not sine, cos of 1 by x into minus 1 by x square. This is it. And I guess this will come out to be your minus 2 by x cube cosine 1 by x, which is your less than 0. So basically this thing proves to us a very simple fact, because we found out earlier that limit x tends to infinity, f double dash x is equivalent to 4. So this thing proves that actually f double dash x, we are not applying any limits here, right? So actually this thing will be greater than 4. Because of this tiny minus sign, this is less than 0 and this thing will be greater than 4. Basically what you can say is, I guess it is less than 0, so the curve will go something like this. Increasing to decreasing, I guess it will be a maxima here. I guess I'm not wrong. There's a maxima here at this point. So yeah, f double dash x will be greater than 4. And now it will be pretty easy to ascertain for us. Basically that is the point why they have given x plus 3. Basically we have to apply our LMVT. I hope you guys know what is LMVT. LMVT is your Lagrange mean value theorem. I thought this could have been solved by intermediate, but I guess no. Better to use your Lagrange mean value theorem. So from that we can write, basically LMVT will be applied for f dash t. Inferred from the question or from the conclusion also you can infer sort of by seeing the option. This is in between x to x plus 3. So now we can write f dash x is equal to your f dash x plus 3 minus f dash x by 3. I hope you guys could understand this. This is just the statement for the Lagrange mean value theorem. And if you don't know this or have forgotten, please do revise it, because this has been asked multiple times in JEE mains as well. Okay. Because let me tell you guys, NTA doesn't, NTA, whatever syllabus NTA prescribes for maths, it is absolute rubbish. Don't go for it. Do the complete syllabus. Okay. This is my personal opinion, because what I would say something on this, I guess. If you notice, NTA has in the JEE main syllabus, as far as of I can talk about my year 2025, they had excluded all tangents and normals present in conic sections. Okay, all tangents and normals present in conic sections, they had excluded completely from the syllabus. That means that if you read your present NCERT and go for JEE mains, then you can solve all questions of maths, which was pretty rubbish, because when I opened my paper, I pretty clearly remember my third question was entirely present on properties of normals in parabola, and also we had to know the equation of the tangent to parabola. Now my point is that if you go on into the exam hall and if you try to differentiate the parabola equation and do all this, this works only when you have values given. But in my question, there were no values given itself, it was completely in variables. So if I spent my time at that particular moment differentiating and solving things, then I could have done only one question in the entire exam. So guys, please don't listen to NTA. And anyways, you are all preparing for JEE Advanced, so anyways you will learn conic sections in detail. So don't depend on NTA, because Lagrange mean value theorem is always asked in JEE Advanced. Okay, you are preparing for maths, so please keep JEE Advanced always in mind. That's it. And now we will return to the topic. So basically this thing actually becomes greater than 4 from here. So now it's pretty clearly proved f dash x plus 3 minus f dash x is greater than 12. It is correct. So our option D is also correct. So basically I guess all options are correct, A, B, C, D. I will check once and tell if I did something wrong or not. I will check the options once. Okay guys, I did a small mistake. D is not correct. Okay, D is not correct because it is given to be less than 6. I didn't notice this thing. So A, B, C will be correct. Please correct this thing. Okay, I thought this was greater than 12. I don't know how I wrote that. I guess while finding out the solution I might have wrote. Anyways, so A, B, C will be correct. D is not correct. It is greater than 12 and not less than 6. So now I guess this will be the end for the Allen questions, and now I have a special PYQ for you guys from old age, like the ancient IIT JEE period. So now we will solve that. So here's the question guys from 2005 IIT JEE, and you can try this out. This is a very good question. Like this will also like this will be little bit lengthy, okay? So don't get frightened. But yeah, a very good question. You can try this out. I will wait for a few seconds. You can pause the video. Okay, so I'm starting off now. So basically, let's first write out our determinant, this big thing. This is 4a square, 4b square, 4c square, 4a, 4b, 4c, 1, 1, 1. And this is your f of minus 1, f of 1, f of 2 equal to your 3a square plus 3a, 3b square plus 3b, and 3c square plus 3c. So multiplying these two will be very easy, or what you can do is you can apply matrix operations here, like you can do a R1 as R1 minus R2 or R2 as R2 minus R3, any two you can do, and I'm directly writing out the result. Okay, I'm not going much into the calculations. So this thing will actually become 4a squared f of minus 1 minus of plus of 4a f of 1 plus f of 2, and this I guess will come out to be your 3a square plus 3a. Now this is only a part of this segment. I hope you can understand, right? Like this is your 3 cross 3 matrix and row cross column. So 3 cross 1 matrix, and here also we have a 3 cross 1 matrix. So basically when we compare, we'll get a 1, 2, 3, 3 rows, right? We'll get 3 rows and 1 column. So basically I'm comparing each row. I will change the page maybe, otherwise this will become clumsy. So after this, what we will write is we will get 4b square f of minus 1 plus 4b times f of 1 plus f of 2 is equal to 3b square plus 3b. Similarly, we will get 4c square f of minus 1. You can see a pattern is sort of forming, plus 4c f of 1 plus f of 2. This thing comes out to be your 3c squared plus 3c. So basically you can see something, right? What you can see is we will actually have an equation 4x square f of minus 1 plus 4x f of 1 plus f of 2, which is equal to 3x square plus 3x, and the roots to this equation are your a, b and c. That is, what is it? So now let's try to rearrange this equation a bit. So this will actually become your 4f of minus 1, and we bring 3x square to this side. So minus 3 times x square plus this will become, I guess, 4f of 1 minus 3 times x plus f of 2. This thing becomes equal to 0. So we know that this equation is satisfied by our x, a, b, c. And now what we have to do is, a quadratic equation is generally satisfied, you know that it is satisfied by more than 2 value of x, and only if that happens such a quadratic equation becomes an identity. And you know what is an identity, right? Like this expression is a quadratic, so it should have had 2 roots, but there are 3 roots, which means it is an identity. If you guys don't know about like these basic concepts, you should read it from number system itself. There is a theorem called fundamental theorem of algebra in the first chapter of JEE in sets, or if you read number system somewhere in class 9th and 10th, there also there is a fundamental theorem of algebra. From there you will know that if any quadratic equation, generally it has two roots, but if it has three roots or more, it means that it is an identity. And in that particular case, we can actually put this and also this individually to be 0, because it is an identity. So 4f of minus 1 minus 3 is equal to 0. 4f of 1 minus 3 equal to 0, as well as f of 2 from here becomes 0. So what we have finally is f of minus 1 equal to 3 by 4, f of 1 equal to 3 by 4, f of 2 equal to 0. Like, this question was very well framed. I love this question. Okay, this question was very well framed. And now let's take f of x to be some, we know that it is a quadratic, right? So px square plus qx plus r maybe. So now if we try to solve this, we can put, I guess, minus 1, 1 and 2. So 3 by 4 becomes p minus q plus r. Again 3 by 4 becomes p plus q plus r. And again f of 2. So 0 becomes 4p plus 2q plus r. And now if we subtract these two equations, we will automatically have q equal to 0. Right? And we can also find out the other values. I will change the page once. So we have q equal to 0 from here. So basically what we can write is p plus r equal to 3 by 4 and 4p plus r equal to 0. So now you can subtract these two equations. So basically minus 3p becomes equal to 3 by 4. So our p comes out to be minus 1 by 4. And from here r will come out to be 3 by 4 minus p. So plus 1 by 4. So r becomes 1. So our p is minus 1 by 4. Q is your, I guess, 0, and r is equal to 1. These are the final values. So our f of x, the function that we need, will become minus 1 by 4 x square plus 1. And now let's read on to the question further. So it's written that f of x is a quadratic function, yeah, we have found, and its maximum value occurs at a point v. So we have to find out the maximum value which occurs at the point v. And now a is a point of intersection of y equal to f of x with x-axis, and point b is such that chord AB subtends a right angle at v. So we have to find the area enclosed in between f of x and chord AB. So you can see basically it's a mix of determinants, matrices, along with that properties of quadratic, along with that properties of your functions, like little bit of maxima minima, that differentiation part, and finally area. So basically 5 chapters almost. That is the level of what questions they used to prepare in these days. Basically this is actually perfect for a subjective paper. Like, if you get this question, this type of a question now in JEE Advanced, then it has to be a paragraph type, obviously. This has to be a paragraph type question because this is becoming pretty long. And maybe in the paragraph type question, they can ask you the area, they can ask you the function, they can ask you many things related to the function and whatnot. Anyways, we have understood the question now. Let's proceed on with the question. So to find out the maximum value of f of x, we have to put f dash x as 0. So let's try to find out f dash x. And also one more thing that you will notice is that at x equal to 0, our f of x is 1, right? And if you find out f dash x, it is your, I guess, 1 is not there and 1 will be 0, and minus half, I guess this thing will become your x. So basically it is 0 at x equal to 0. So basically we have got our point v. Our point v will be 0 comma 1. If this was paragraph type multiple choice, then they could have asked you this. So now we have to find out the point where this particular curve meets the x-axis. So to meet the x-axis, basically we have to put y as 0. So from there we get a as minus 2 comma 0. I hope this is simple. And now we have to let a point b also, because b isn't given to us, right? Let's take it to be something, say, what should I take? Let's take it to be h comma 4 minus h square by 4. After putting h, this will be, I guess, 4 minus h square by 4. And what I will also do is I will try to draw a rough diagram of this, because without drawing the diagram, this thing is becoming a bit difficult. Okay, like a rough graph of what is happening. I will try to draw that. So here's approximately our diagram for this. This is the curve, the parabola. This is a parabola, right? Y equal to minus 1 by 4x square plus 1. And here somewhere the point B will be. And our shaded region required, I will try to shade this with a, say, blue color. So our shaded region for this thing will actually be this part. I'm drawing with lines. This thing will actually become our shaded region, including this triangle. Okay, this is our shaded region. So we have to now find out the area and all, but before that we have to also find out B. Okay, that's the main target. So if you guys notice one thing carefully, angle AVB is your 90 degree. I hope this is no confusion. Angle AVB is your 90 degree. It's given. So what we can say is MAV into MBV, the slopes, their product will be minus 1, right? So, and we have taken B to be this thing. So from here we will actually get, I guess, H. Let's try. So this thing becomes 0 minus 1 whole divided by your minus 2 minus 1. And this is your whole multiplied by, I guess, 4 minus H square by 4 minus 1 whole divided by H minus 0. And this is equivalent to minus 1. So let's manipulate this a bit. This is minus 1 by minus 3, so 1 by 3. And this is your 4 minus h square minus 4, so minus h square by 4h equal to minus 1. Minus and minus are cancelled. H obviously can't be 0, right? H can't be, I guess, 0, otherwise this and this will coincide. So we can cancel this h out freely. And now our, I guess, our h comes out to be 8. Just a minute. Okay guys, there was a mistake. This is minus 2 minus 0. That's why I was thinking why h is not coming out to be 8. This will be your half. Okay, h will come out to be 8. So now we can calculate b. B will be your 8 comma 4 minus 8 square by 4, and this is, I guess, coming out to be minus 15. This is your point B, and I am also writing for reference in the curve. So now I guess we are fully ready, not fully ready. Like, if we have to find the area, we need the equation for this chord AB also. So let's find that out first. So what we need is our equation of chord AB, which we can directly find out from 2-point form. This thing will become y plus 15 equal to your 0 and minus of minus 15. I am taking this whole divided by, I guess, minus 2 minus 8, and this is x minus 8. So y plus 15 is equal to 15 whole divided by minus 10, x minus 8, and this gets cancelled. 5 3 is a 15, 5 2 is a 10. So 2y plus 30 equals to minus 3x plus 24, and this comes out to be a 3x plus 2y plus 6 on bringing this to the left hand side equal to 0. So this is our one curve. Another curve is our y equals to minus x square by 4 plus 1, and I guess rest of it we have everything ready with us. So now to find out the area, I will try to write out the expression. Okay, like I will say required area. So this thing actually will become integral minus 2 to 2. Why minus 2 to 2? I will explain in the curve, just a minute. Basically minus 2 to 2 is this upper area, and with this I will write out minus 2 to 2 minus x square by 4 plus 1 dx plus integral minus 2 to 8. Here is minus 2 and this is 8. This particular thing, because we can't, like, we could have found out a triangle area, but better not to find, because otherwise that would have become much more complicated. Better to do it with integrals. So this thing becomes your minus of, and if we try to write it this from here, this is becoming y equals to your minus 6 minus 3x, I guess, by 2. So minus of minus 6 minus 3x by 2. dx. Why a minus of minus? Minus because this area is under the x-axis. Please remember that. You have to take the signs, okay? And from this, we will subtract that area, that is integral 2 to 8. Basically this part. Here is 2. And I guess I could have drawn the diagram a little big. So 8 is not so close to 2, but anyways. This is 8. So basically we will subtract this particular part, okay? The area that is being like bound by the parabola in this particular region. So this thing is becoming minus of minus x square by 4 plus 1 dx. This will be our expression for the final answer. So let's find this out. This will be a little bit of calculation. I will do it. So let's solve this now. I hope this area expression was clear. So this thing actually becomes, this is an even function. So 2 integral 0 to 2 x, like 1 minus x square by 4 dx. And we can write a plus of integral minus 2 to 8. And this thing, I guess we can take out the half outside. Okay, let it be. This thing will be half 6 plus 3x dx and plus of 1 by 4 outside, integral minus 2 to 8. This thing is your minus x square plus 4 dx. So this becomes 2 times minus x cube by 12 plus x, I guess, yeah, 2 to 0 plus half. This is 6x and this is your 3x square by 2 from minus 2 to 8, and this is your plus 1 by 4 minus x cube by 3 plus 4x from 2 to 8. So I will quickly try to calculate this thing out for you guys. So here's the complete calculation, guys. I calculated this whole thing. You can also do. I'm not going much into this calculation. This will be a little hectic. And the final answer for this question will come out to be your 125 by 3 square units. This will be the final answer for this question. Pretty like sort of hectic calculation here. But yes, you can't deny the fact that this question was a god level question. A really god level question. Okay. So that's it for today, guys. I guess I will try to bring in more such questions of previous year JEE Advanced because this is something I liked very much. And if you have any doubts in any place in the video, you can always ask out to me in the comment section, and also keep dropping your recommendations and all, whatever you have and whatever you need. So that's it for this video, guys. Thanks for watching, and do like, share and subscribe if you like the content of this video. And thanks for watching.